Hey guys, it's me. Yep, it is. I'm here to make or to show you what I have already made, and that is a motor. If you were in grade 11 physics, this is probably going to be part of your mark, making one of these. And if you think about a car motor, it sounds complicated, but really you can make a pretty simple one out of conducting wire and a magnet. Don't worry about the propeller on the end. If I sound a little flustered, it's because I have a big family and a small house, so this is my third time making this video. But anyways, so first thing to do for the third time saying is you're going to need copper wire. If your teacher has copper wire, use hers because it'll work better than yours probably, because I tried to use this kind of wire for the coil and it did not work at all. So use her wire. You're going to need to coil it around a cylindrical object, so maybe a glue stick, but it's got to be fairly small because the smaller it is, the faster it'll spin, diameter wise that is. And you're going to need to make sure that you have arms, an arm length coming out from the sides, because once you make that coil, you're going to need to squish it down into a circle like this, and then you're going to use those arms to bend in and around and out of that coil to keep it together. And then those arms are also going to need to go through these conductors on the side, which should have a circle in them, just an open circle like that, no strings attached, so that it can spin very smoothly, like you saw. Once you've done that, you're going to need to find a magnet or two stuck together, but that's okay because it just flips the poles to all go the same way, or the dipoles, I mean. But if you're in grade 11 physics, you should know some of that already. And once you've got this part set up and you've got a magnet underneath and you've got a coil with a relatively small diameter and thick but maybe not too thick coil thickness. Well, I used the same word too many times there. Somebody tell me a different word to say. Now, make sure it's not too thick because that'll weigh it down. Now you can see that mine kind of stays with the opening pointing up. That's good because it means both coils are the same mass, which will help for it to spin easier. Once you have these conductors on the sides, I would suggest using alligator clips, but you can use naked wire as well. Just make sure that you're not grounding it. Make sure there's a plastic coating so that when it touches the ground, it's not letting out any of that charge, because you're going to need all of the current you can get. You're going to need a power source. Now I would recommend about 6 volts of power, because if you have like 24, you will light this on fire and melt things. Trust me, I know from experience. So go with about 6 volts, I'd say. Now if you have a massive motor made out of like car parts, yeah, maybe you should go bigger than 6 volts. But if it's this small, 6 volts is nice. So once you have that power source, you're going to connect the wires from the conductors here, the conducting stand, to the power source, and that will create a current going through this. And when the current goes through the arms and into the coil, it'll actually create a magnetic field around it, so that when this magnetic field moves towards the magnetic field of the magnet, it's actually opposite, and so the magnet will push it around and around. Now there is one problem with this. It will only push it around once, and maybe more like, it'll go more like that. Okay? And if it does get around, it won't push it back anymore. Okay? This is what I mean by finicky. I haven't said finicky yet in this video. See, this is what happens when you make multiple videos on the same thing. So what you want to do to solve that is color one side. You can see the black marker on the one side. Not one side, not like one arm. You're going to put it on both arms, but you're going to make sure that it's on the same level ground on each arm. And what that'll allow it to do is flip the poles for every spin. So say this is south and this is north, well, that's going to attract. Now, it'll probably start off opposite, so let's say this is north and this is north. So that'll allow it to flip, but now the poles are the same, right? So opposite down here, but it flips, and now the poles are the same. And what the marker will allow it to do is every time it flips, the current will change the magnetic field. It'll make it opposite with every spin because of the marker. So that'll make it, so if this is north, and this is north, it's going to repel, but then the bottom's going to be north. And now the top's going to be north, and north, and north, and north, and north, and north. And it's just going to keep flipping it so that it keeps spinning. This is very finicky, so you're going to take a lot of tries in this. You're going to have to check the marker. You're going to have to make sure those arms are straightened as much as they can be, because this has to be perfected to work. And it takes a lot of tries, so clear up your afternoon, kids. What else to go through? I told you that you don't need that propeller. That's for the rest of a machine I'm making, and probably something that you'll be assigned to do in some way, perhaps, is a Rube Goldberg machine. Now what that does is it's a bunch of mechanisms that work together to do one simple thing. So I'm not going to tell you what my Rube Goldberg machine does, because that'll be covered in another video. Just to help you guys out on the full mechanism of that, or just give you guys ideas, which I'd prefer to giving you guys an instant answer, because it won't teach you anything. So I hope you guys liked this video. If I was missing anything, if you wanted me to add anything, or if there's anything you need answered, ask in the comments below, because I do check it. And I hope you guys all have a great day, and I'll see you later. Goodbye.